slideshow is starting. So can you all see my screen?
Yes, we can.
Yeah, okay. Then I will start the presentation. So thanks for having us today. My name is Mirko Melisi, as Rishi already mentioned. I'm currently working as a commercial lead within the data-driven advantage team from Howden. And today I will give an introduction on one of our products, which is Howden Uptime. And Uptime is a performance monitoring tool that will support you with data-driven decision making for your operation of your equipment. In this case, we will discuss cooling fans related to ACCs. We already have Uptime installed on quite a large group of assets that we produce within Howden. Currently, we have Uptime installed on, let's say, reciprocating compressors, screw compressors, turbo blowers, centrifugal fans, and maybe more important for this meeting, as we are discussing ACCs, and we also have Uptime on large axial ID and FD fans, and currently developing something for air preheaters. But today we will zoom in on the cooling fans and ACCs. So looking at the content, the following topics, I will start with revolving around you. So it's a bit of a background why we developed Uptime. The next topic will be on the digital twin, which is quite a buzzword lately. So I will explain what we consider as a digital twin and how we are using it. The next point will be on data capturing and connectivity. So the backbone of all our digital solutions for Uptime. Very important, how do we come from data to added value for the customer? And the last topic will be on specific, what type of hardware are we aiming to use for cooling fans and ACCs. So starting with the first one, revolving around you, which is a brand promise from Howden to our customers. When we started a few years back, developing Uptime for the first, at that time it were compressors. For the first products, we first started with quite a large VOC, so asking our customers what are the needs, and we actually got a lot of valuable feedback, and the main issues and topics we received were having critical equipment, which is, in many cases is still unmonitored, having unbound plan time, and where it's difficult to find the right root cause and define the right countermeasures. And we got questions like, how can you increase or align maintenance intervals? How and when to maintain process critical equipment? How can we increase asset efficiency? And how can we move from, let's say, a condition-based maintenance program to more like a predictive maintenance program with only constrained resources at site. And actually, through the years when we were developing Uptime, we see that these questions are not typically for compressors, but we also see these questions from the same from other customers for fans, heaters, and blowers. So with these topics in mind, we started creating Uptime, and this will lead us into the next point, the digital twin. Which is really an important part of our Uptime offering. I will explain a bit more about the in-depth asset analytics that it's capable of, the predictive analytics, and a slight introduction on let's say data-driven analytics and model-driven analytics, both ways of analyzing data, but slightly different. And we'll get a little bit more into detail in the following pages. So going to the digital twin, which I already said is the core of our Uptime portfolio. It will really give you in-depth asset analytics, and the combination of the data and the model-driven models. So these digital twins are a great tool for our technical experts to give the best advice to our customers regarding maintenance and performance monitoring of their assets. looking at the model-driven digital twin part, that is really based on let's say the OEM knowledge and that Howden has with more than 160 years experience at the moment with a lot of our products. We currently have that running for reciprocating compressors and turbo blowers. The beauty of this is that it uses, let's say, the fan selection or the compressor selection models that we have within Howden, and these are in real time connected with the measurements that we are doing on site, and that's really helpful in analyzing data and seeing whether things are off spec. And yeah, it's a great tool, and the beauty of it is that it doesn't require any historical data to train the model. So it's an added value from the get-going that you install uptime. On the right of the screen, on the bottom, the points, what are we aiming for? So it's detecting rotating equipment failures before they occur, help identifying the root cause, understanding the impact of change in operating conditions on the equipment and process performance, and also moving critical equipment maintenance strategies from reactive to full predictive. So when we start with a new development for uptime, and in general, it's always important to check what type of asset you are aiming for. So are you looking to develop a digital solution for more, let's say, homogeneous assets, which are identical assets, often also operating in identical environments? Or are we looking for heterogeneous assets? These are similar assets, but not identical, and often also operating in different process conditions. And I think 95% of the products from Howden are more heterogeneous assets. And that's important to keep in mind if you start developing your digital twin types. So on the right, I have made an overview on you have data-driven digital twins, the physics-based digital twin, which is based on OEM knowledge and event selection models, etc. And the best way, what we are currently already have in place for some of our assets is, let's say, the hybrid approach, where we both use data-driven and physics-based models to do the analytics. If you look at data-driven models, they require data. Often they are less complex, but limited in applicability. So it's often difficult to use them in the right way for heterogeneous assets. And then we have the model-driven analytics, which require domain knowledge, quite complex, but broader applicable. So going a bit deeper in the model-driven analytics. So the physics-based digital twin, what does it do? It uses the thermodynamics and equations of state of assets. So the calculation models that we also use to design new build machines, or that we use to calculate revamp projects. And it has an asset agnostic core. So depending on the product, but with many products it has an asset agnostic core. So it's applicable on both Howden and non-Howden assets. It's self-learning, and what it does on the right, you can see an example of a PV chart, and this is for a reciprocating compressor. I use this example as this is something we currently have in place. And what you can see here is an overlay of, let's say, measured values, but also calculated values. And if we see any deviations in the PV chart between these data sets, this will give an indication if there are any failures, in this case with a compressor. Now looking at cooling fans and ACCs, these are typically operated in quite harsh environments, and wind influences are quite big, and this leads to a wide variety of failures and performance issues. And yeah, through the years we have acquired a lot of knowledge, so we have a lot of domain knowledge about performance performance of cooling fans. And also we did a lot of mechanical measurements on ACC fans. So we have a lot of data available already within Howden. And yeah, what you see on the screen is the effect that increases on loads of the blade if the wind increases. And typically side winds lead to distorted inlet airflow, which you can see on the top left of the screen. And this will lead to increases in dynamic blade loading and also vibrations. On the right, you can see that the increase in the blade loading due to a distorted inlet airflow can be seen in the spectra, so in the FFTs. So we are aiming to do a fast Fourier transform, which will be a big benefit to locate the failure modes that's connected to what you're seeing. So we would typically expect to see certain harmonics under stable operations, and others, we could see as a result of resonance occurring due to increased dynamic loads. Coming to the next topic, which is data capturing and connectivity. Brief introduction of the data journey. As we already have uptime in place for a lot of products, we also have quite a solid data capturing and connectivity system in place. And yeah, the system consists of 4 parts. The first part is the asset, which represents the machine that delivers, let's say, operational data via sensors, which is stored in the DCS PLC, or it can be sent directly from a sensor kit. From there, the information will be sent via an edge gateway, and it can be sent land-based, but also via satellite. But at the moment, 95% of our uptime installations are using a SIM card, so the cellular network, to send out this data into the Howden uptime environment, which is running in the Microsoft Azure cloud. And yeah, what's good to say, at no time does the data touch the open internet. So AT&T have given us a group of IP addresses that can only be used by Howden. And these are whitelisted as the only devices that can communicate with the uptime platform. The edge itself is more or less treated as a Howden laptop, so with the operation system kept up to date and remotely patched and protected using next generation antivirus software. The uptime portal itself, we are working together with ThingWorx. So ThingWorx PTC is our platform provider, and it supports HTTPS authentication, which requires our users to establish a web session using a username and a password. So if you have uptime installed, you can access all the data from anywhere that you want. The only thing you need is an internet connection. So from data to added value, what's the goal of uptime? Where do we focus? And how do we show, let's say, the results? Starting with the goal. The main goal of uptime is to reduce unplanned downtime by predicting failures before they happen, and to detect whether the asset is running as optimal as possible. So if you look at the screen, on the left we have the digital twin health indicator. In the beginning, it will be 100%, so that's your normal operating window. And there's always a point that your machine will slightly go down in the health score. And the aim of uptime is to detect as soon as possible that the normal operating window is changing, and that we can take mitigating actions. And as we can see, let's say deviations on the normal operating window quite early, this will increase the predictive action window. So it will increase the time for the maintenance teams on site to plan their maintenance, make sure spare parts are available, and the right resources for the service intervention are there. So the main idea is to really save time and to plan your maintenance better. Besides planning your maintenance better, we will also be able to see, depending on the sensors that are installed, whether the performance is as it should be, and we could also give advice on how to run your equipment. So when we start developing uptime for a new product, and in this case, we already have had a lot of discussions, and we're currently planning to install an uptime system in Q2 next year within an ACC and a cool fan. So what we typically do is when we start, we are listing all the main failure modes and also the performance optimization modes, and we are coupling those with sensors that will be able to detect whether normal operation windows are changing. So looking at cooling fans, the commonly occurring issues are high vibrations, fan rotor failures, bearing failures, gear failures, and reduced performance. And from experience, many of these are caused by load variations caused by increased side winds. So what we are leveraging is the fact that we can separate drive and wind issues as we are doing a spectral analysis, so an FFT, fast Fourier transform, in real time. And that's a big difference with typical measurements, which are often RMS values, and which will indicate when vibrations are getting higher, but you don't know where they are coming from. So I think adding the FFT to your analysis is a great win. Yeah, additionally, with cooling fans, we want to be running comparative analytics between identical assets as well. As we know, the vibrations are usually affected by side winds, so we will be able to detect when vibrations are caused by the wind, or if they are actually an indicative problem of the fan itself. So this is basically the setup that we are aiming for cooling fans in relation with ACCs. From the sensors, as said, we will send all the information via an edge device directly into the uptime portal. This is a screen that shows what we are envisioning to show with the installation next year. So you can see the current status of the fan with the health score. So we will use colors. Green, everything is all right. Orange, there are minor problems, and red, you really need to get to this fan as there are big problems. Showing information like fan speed, fan power, and also alarm histories and current alerts. And this is, let's say, the basic setup from here, and probably this is how it goes with development of these type of systems. We regularly have contact with the end user, get feedback from them, and then so in that sense we will also develop new features if requested by the end customer. Another screen that we want to have available in the portal is this one, where you have an individual look of the fan, and it will also benchmark that fan together with fans that are adjacent fans, which will give information for technical experts. We will look at vibrations over time, and what's not on this screen, we are aiming to add an FFT 3D waterfall. This is something we currently have in place for reciprocating compressors, and this will give a great view of development of your vibrations over time, but also you can see where they are developing, and so it's not the total of the RMS that we are only looking at, but we are really looking at specific frequencies. And these can be related to, for example, blade passing frequencies or imbalance. It could be structural frequencies. So yeah, it will give deep insight of what's going on with this fan. And together with the simultaneous input of wind measurements, we can also link them and see, are these issues related to wind, or is there something else going on? So it will really give deep insights. Fan. So coming to the hardware part, as mentioned, we are currently developing our first uptime system for a 3-cell ACC unit. So the measurements will include accelerometers. They will be placed on the gearbox to measure radial and vertical vibrations. And with these measurements, we will be able to see the difference between structural and drive vibrations. We will have vibrations monitors connected to the edge device, which will be used to send out raw data continuously or periodically into the cloud, ready for processing in real time. We will also be using a propeller anemometer to measure airflow at the fan. And this one will be used to track comparative fan performance versus motor power over time, and as a function of wind conditions. Motor performance metrics such as speed and current can be measured directly, but in this project we will get this information directly from the DCS. So it's good to mention. So it's good to mention we can get information directly from the sensors that we install. But if the customer has valuable information available in the DCS, we can also link to the DCS and get that information into in the uptime environment. And finally, side winds at the ACC will be measured using an ultrasonic anemometer, which can measure fast enough to detect wind gusts, which is again important, as wind is a huge factor on vibrations within cooling fans, especially in ACCs. Trying to get to the next slide, but it seems stuck.
Touch the screen with the cursor and then move it.
Yeah, cursor isn't doing anything. That's a pity. Before the last slide. I'm trying to get back, but no, it's yeah, okay. It's going to the next one. So yeah, this as we only had 20 minutes, it's quite a short presentation. If anybody's interested in more information, we can always set up another meeting. But to end and to recap this presentation, and the three pillars that we are focusing on are reliability. So reduce unplanned downtime by predicting failure before it happens, reducing maintenance cost and extending outage intervals, focusing on energy savings, so optimize equipment process and plant performance, resulting in substantial energy savings and reducing environmental impact. And maybe the most important one, which I think I didn't highlight enough, if you get uptime on one of your assets, uptime is a service model. So besides that, you will have access to the uptime portal with all the information. You will also get support from so proactive support from the technical experts from Howden. So they will proactively also monitor your equipment and will send you event reports, monthly reports on the status of your equipment. And what we are currently seeing with the uptime customers that we have, that we call it trusted advisor, but that the relationship between Howden and the customer is really growing, because we can really give advice that brings added value for the customer, with information that they didn't have in the past. So yeah, that was my brief introduction. I think Rishi, we can go to the questions now.
Okay, yeah, really good presentation. I know as with resources, there's restrictions on resources, and as plans to work with less and less people, it's really important to have these kind of softwares and like technologies in place to help with the diagnosis. So really good product. Yeah, if you have any questions, you could either put them in the chat box or raise your hand, and Scott can unmute you. We have a couple in the chat box. We'll start from the bottom. Can the data gathered and analyzed in uptime help to optimize ACC fan blade pitching?
Good question. I think I can answer that one. That depends on the sensors that you are aiming for. The current setup that I presented will not give a complete overview of the duty point of your compressor, and it also doesn't measure let's say the delta P over the ACC. If you do things like that, then we could grow into a situation that we can also give automatically advice on the right blade pitch. Yeah, so theoretically, I see something is possible. It's not the setup that I currently presented. And Jacques, if you want to add something to it, then please jump in.
Yeah, thanks, Mirko. So just to elaborate on that question a bit more, I think at the moment, what we're hoping for is to be able to track performance over time. So performing a detailed performance measurement continuously is really, really challenging. So what we're hoping to do is use a reduced set of measurements to track performance. And if that then shows that we need to change the blade pitch over time, then yeah, that would be a good outcome.
Okay, one more question. How many ultrasonic anemometers do you suspect installing on a 36 feet fan?
Do you mind if I answer that, Mirko?
I was hoping for it.
Okay. So the ultrasonic anemometers at the moment, we are planning to install those not on a per fan basis, but rather on a per site basis, because those we purely intend to use to monitor the side winds and the gusts. So they measure faster than a propeller anemometer can. The propeller anemometers we want to install inside the plenum chamber to, as I previously mentioned, track performance over time, while the ultrasonic anemometers give us the ability to look at wind direction and speed at a much faster rate, so we can see if gusts are coming through. So that will not be on a per fan basis, but on a per site basis, and probably be situated on the corners of the ACC. So depending on how many corners are exposed to the dominant winds, that then we can decide how many of those ultrasonic anemometers we need.
One more question is, can you ask Jacques to discuss the question he answered in the chat in the forum? Okay. So there was a question asked by Daniel Els. The stiffness of the composite structure, ACC fan blade, reduced under fatigue loading. A good indication of future failures is a reduction in natural frequencies. Any thought on monitoring changes, example, bending frequencies?
Yeah, so I tried to answer that in the chat during the presentation. At the moment, we are focusing on only measuring on stationary components, because if we are to put sensors on rotating components, it increases the cost of the system quite substantially, because then we're talking about things like strain gauges on blades or load cells under bolts. So there is a cost implication there. There is definitely a benefit as well, but we need to weigh that up with what the cost is going to be. So definitely there's benefit, and it's something that we can consider if we are expecting it to be really, really beneficial on a site-by-site basis.
Okay, one last question is, what is the average cost per ACC fan?
Maybe I can answer that as well, because I've been looking at the data acquisition systems that we've been using. It's a difficult question to answer, really, to say what the average cost is going to be, because we've only really developed this for one site. And because we're still developing the system, we are using more sensors than we think we might use at an average site, because we want to learn from this experience. But there's always I wouldn't say a risk, but there's always a big challenge with cooling fans, to get a cost price that makes sense to the customer. And also this needs to be handled as well on a side-by-side basis, because now we're installing on an ACC with 3 fans. So you can imagine that if one of those fans go down, you have a massive loss in cooling capacity. But on a larger ACC, that's not the case. So you need to, as a customer, and well, in consultation with the customer, we kind of need to define what cost makes sense for that specific site. So I don't have a fixed cost, unfortunately, but that's something that maybe if we have further discussions, or if you have specific sites that we can look at, specific needs, that's something we can talk about. So a vague question, a vague answer. I apologize for that, but I don't have a real answer.
All right, thank you guys. Thank you for the presentation. It's really informative. We'd like to move on to the next presentation. It's going to be Hoop from ACC Team Technology BV, and he's going to talk about ACC maintenance.
Good morning, everybody. Okay, I'm Huub Hubrechtsen, actually the owner of the ACC team in the Netherlands, and we are specialized in designing, improving, repairing, upgrading ACCs, all sizes, and we actually basically do in-house the engineering, supervision, control, commissioning, making use of contractors to do the actual work. This presentation is actually put together in order to share information from experience. Experience comes from various plants, in most of them in Europe, but also outside. And we would like to just to pinpoint certain aspects which we found, and to share that with other users and suppliers of ACCs. Basically, if you compare maintenance costs of ACCs and wet cooling towers, the ACC is actually not that bad. We have seen plants where we did some work, we came back 1 year later, and certain personal effects of the people that did the previous job were still there. Nobody noticed. So yes, ACCs do need maintenance, but not so much as a wet cooling tower. Okay, the items that we would like to share is something about fans. And this is not about, say, the construction of the fence or whatever. We just heard that. It's about, say, the use of fans and problems experienced. Gearboxes, motors, pumps, and the evacuation system. Okay, we recently encountered a ACC with an incinerator plant. And the plant was in operation for almost 20 years. And by investigations during maintenance, we found various cracks and damages on the blades. And we found that actually this fan had to be replaced, which we did, and investigated the damage together with the supplier. And this was just a typical case of where due to, say, vibrations, conditions, weather impact, etc. From this actually example, we found out that it is quite important to have regular checks, I would say at least once a year, to inspect the blades to see if there are no cracks. There are very simple tricks and ways to do that and to prevent possible failure of the fan. Because if the fan will actually lose one blade and the vibration monitoring system is not working perfectly, you get quite a lot of damage. So this is just something that we found in practice, but it was not the only one. We recently had a fan on a wet cooling tower, which was made by a supplier not very competent, where they used the wrong kind of resin. And after 3 years of operation, trying to touch the blades, we could go through the blades with a screwdriver just by hand. The fiberglass was completely disintegrated. Something people should actually be aware of and to check if the materials are correct. Another problem that is just a problem due to wear, but also problems with debris in the air. Yes, we know that for wet cooling towers you use an epoxy coating on the front edge, but if you have, say, areas such as incinerators, where you also have bigger dust particles in the air, wear can be very, very quick. So this is also an item to investigate, to see if this is the case. And if this is the case, you should actually, again, do regular inspections to see if there is nothing wrong with your equipment. Another point is that we heard it already in one of the other presentations, that is the leaking oil from the gearbox. This oil normally is not just coming from the gearbox, but it comes from the shaft. What's happening? The gearbox, the gears and bearings are lubricated by oil. That goes very well. However, it's in most cases, the outgoing bearing is lubricated with grease. And the outgoing bearing is a very important part, because when you got side winds, the fan will actually start rocketing. It will actually move a little bit on one side up, the other side down, and that is actually, while it is turning around, getting the bearing quite heavy loads. If the bearing is not, say, strong enough, after a while, the bearing will actually start wearing out, giving some movement on the shaft, and then the oil seals between the actual gearbox, oil lubricated, and the grease lubricated chamber for the end bearing will start leaking. And that's the beginning of the end, of course. In this picture, you can see how the stains on the fan ring become visible, also because the dust sticks to it. And this is actually oil from the gearbox. And that oil has actually passed through the gearbox end bearing chamber, and is then actually by the centrifugal forces thrown to the fan ring. If you see this, you know your gearbox is going to fail very quickly. This is something that we have been experiencing lately for quite a few times, mainly for, say, sites which are having, say, ACCs of, say, 10 years plus in operation. So if you ever see this kind of pattern on the inside of your fan ring, you know what's wrong. One of the things that yesterday we also heard, that water in the gearbox is a very, very dangerous thing. That's why nowadays most gearboxes, we already do this for more than 10 years, but we actually supply them with breathers. And those breathers, there's a silica gel inside, and it will actually filter out the vapors, water vapors, because due to temperature changes, you get air going in the gearbox and air going out of the gearbox. And if you don't do anything, if you don't, say, trap the water vapors, you will get the water in the oil. And that's actually something that, is actually damaging your gearbox, your gears. What we normally advise is that if you use mineral oil, you exchange the oil every year. If you have synthetic oil, you can do that every 2 years. And also, when you do this, at the same time, check your vibrations. Take a sample of the oil to see if there is no funny materials on the inside. And that's actually one of the first steps to prevent your gearbox to fail. Motors. Yeah, motors, although they're quite important, and most of them have a lifetime of 5 to 10 years, but for reliable operation, you should have maybe one in stock, but not more, because most areas in this world have workshops around where electrical motors can be actually overhauled in a matter of a few days. So that's why motors should, nice to have a spare one in order to pick up production very quickly, but it's not a very important item that must be kept in stock for more than one. Evacuation systems. Yeah, the evacuation system in practice do run quite reliably, but there are some issues where actually a vacuum system should need some maintenance. As they are normally, say, built with redundancy, the most vacuum systems have, say, two, say, operating ejectors, and one is operation and the other one is spare. So if you do some maintenance, you just switch off one, and the other one is in operation, and the one that switches off is having the maintenance. Maintenance on them is relatively simple. The most important items that can actually start leaking or something like that are the gaskets. The ejector nozzles themselves are nowadays very seldom wearing out. You should actually, with every maintenance exercise, you'd actually check them, because you can have some erosion, but the most important thing are the gaskets, because the unit is actually locally heated up to 250, 300 degrees C. It expands. Then after a while, you switch off, you go to the other one, and it cools down again. That thermal movement is actually damaging your gaskets. Just a little example, was in the power station, 750 megawatt power station in the UK, where I came around and I saw that they could not achieve a back pressure below 135 millibar. So I asked them, he said, well, what's going on? I said, well, you don't know. He said, yeah, your vacuum should be about 70. Yeah, we know, but it doesn't work. We actually have in operation all the vacuum units we have. I said, oh, hang on. So we went and have a look. They had 3 liquid ring pumps for startup and 2 steam ejector system for operation. So I told the guy, I said, well, switch off the liquid ring pumps, because they don't do anything below 150 millibar absolute. So we went to the other ones. And then we noticed that one of the steam ejector systems was completely cold. There was nothing going through. He said, well, I don't think this system will actually be in operation. So switch it off. So instead of 5 pumps, he only had 1 left. We went to the control room and he had 70 millibars. And he didn't know why. He said, well, you used a few faulty pumps, and that is actually costing you a lot of money because your operation goes down. But okay, later on, we have actually done some maintenance on the steam ejector system, and that was the solution of the problem. Yeah, the pumps. Oh, also the pumps. We have pumps in an ACC, one pump that is just pumping the water from the tank to the preheater or back to the tank again. And another kind of pump is the drain pump, draining the drain tank and bringing the condensate to the tank again. And those pumps should always be, say, installed with a redundancy of 100%. So you have 2 pumps next to each other. And then you can actually use 2 pumps in emergency cases, which seldom occur. But the main thing is that if a pump must be repaired, you switch over to the other one. And the one that must be repaired, you do that, have some spares around, seals, gaskets, bearings, things like that. And that's it. So relatively simple, but quite important that you know what you're doing. That was actually my contribution to the experience sharing.
Thank you for the presentation. Really, really informative. I think for all of us that operate plants, gives a really good overview of what parts we need to stock when it comes to the ACC and sort of the overall, operation, what things we should look for.
Yep.
Yeah, if anyone has any questions, they can type that in the chat box or raise their hand, and Scott can unmute you. We have a question. 1 or 2 years frequency of oil change seems very often. If oil tests like Ruler, RPVOT, etc. show that there is still remaining life, would you recommend to continue with the oil or trying to work on condition-based maintenance?
The point is that from experience, we have tried with certain customers to exchange the oil much later. And in most cases, that resulted in problems afterwards. And if you have, say, simple gear, an electrical pump, an oil change is not such a big deal. It is relatively simple. And actually, it brings in, because it's not so much that the oil will wear out, it is actually that the oil will be contaminated with certain items. We recently, in plant in Belgium, we found in certain gearboxes that there was a sort of burning products in the oil. So the oil was partly, say, overheated on the inside. Okay, it was not a new plant, and we actually recommended to check the gearbox again, do some measurements on vibrations, and at least change the oil and have some fresh oil inserted, and then wait for the results of the vibration investigation.
Okay. One more question. Have you ever seen a case where gearbox output bearing is under design for wind load effects?
Yes. We have seen that quite often. As a matter of fact, when I was working for Balcadeur, we had a project in Dallas. That is where we recently, with the ACC user group, went for a visit. And over there, we installed gearboxes. By the way, they were from Flender. And at that time, Balcadeur was the owner of Flender. So the big boss told us, you are going to use a Flender gearbox for this project. So, okay, no problem. And that gearbox had an outgoing bearing that was much too weak. That was not in the position to hold all the forces of a rocketing fan. So actually what we did is we actually installed a kind of a bearing shaft on the outgoing bearing in order to to actually get all the forces by the rocketing effect, not via the gearbox, but via this special bearing shaft. And because the first test we did, the end bearing was actually going out very quickly. It could not hold the forces of the rocketing fan, especially with heavy winds. And then it actually it should be strong enough. It should also have a service factor of 2.5 to 3 at least, and then you can actually have the unit work for quite a while.
Okay. Is there any technical motivation for the following? Having a gearbox with dedicated oil spray nozzles directed into the gear mesh compared to an oil rundown from the top side of the gearbox.
Yeah, it's a matter of the design of the gearbox. The certain gearboxes are designed in a way that things like that, it doesn't matter how it is designed. For those gearboxes, they have taken the optimal situation. 2 years ago, that was a gearbox from Air Liquide, and there they had a kind of a gearbox that had a lubrication system that was not 100% fit for duty. And that gearbox went out twice in 3 years for overhaul. And we told them that I don't think this kind of gearbox is suitable for you. So go for another one. And then they decided to go to an P4 from Hansen, and the problem was solved. So it is a matter of the manufacturer. If he comes up with a good solution, it normally works. That is, we have seldom, say, problems with this, but sometimes a model does not have the right, say, layout, and then you have it.
Okay. Question from Axel. What are typical oil cleanliness levels you've observed?
Well, what do you mean by oil level?
Oil cleanliness level. I guess.
Oh, that one.
Yeah.
Well, actually, the point is that if you take the samples from the oil, then what you see is that you say, well, hang on, I have here, say, 10 gearboxes, and the oil samples we get out, they all have a different color. And then they analyze it, and they say, well, yes, the color is different. The contamination is a little bit different, but in general, 9 out of 10 of these samples are okay. So it's not very clear why and how that is happening.
Okay. Anyone from okay, one more. Do you have some FFD spectra related to common vibration problems on the gearbox that you could show?
Yes, we have. Basically, what we do is, so if we design a new setup, we actually make an analysis of the vibrations, because the vibrations in a ACC are actually related to each other. First, you got the structure, then you got the fan bridge, then you have the blade passing frequency, and then you have the gearbox itself and the fan. And they all can have some vibrations. And what you should do is you make a design where all the frequencies are not, say influences each other in order to get a resonance. And a nice thing about, say, frequency inverters is that with a frequency inverter, you can actually afterwards say, okay, let's go through the whole frequency band and see where we have unacceptable vibrations. And then you program the inverter not to stay at that specific frequency for longer than a second. So you can pass it, but you can't stay there. And that is actually what you actually find in practice.
Okay.
But yes, it does happen. And also a very important thing is that, one item can influence the other item. There was a project in Mexico where the client wanted to have a very fast-going, low-price fan. And those fans, they created a kind of a frequency which was too close to the own frequency of the fan bridge. And then, the thing started to vibrate and resonate, and it was awful. You could hardly run it, and it was actually, unacceptable. And then we actually converted the fan bridge steel frame into, say, a kind of an old-fashioned railway bridge with trusses, and the trusses were actually the handrailing. And that was actually, instead of just having a normal, simple handrail, which doesn't do anything, we actually made a structural frame of that. And that structural frame actually changed the own frequency of the total bridge, make it much stiffer, and the resonance was gone. And the unit is still working now. And this is just something that, we actually are the people that build plants. People call us in when there is a problem. They said, okay, something is wrong, please have a look. And then we must come up with some ideas. And because we see so many plants from inside, you can combine certain results and say, hey, hang on, here they have that, there they have that, they have problems here. Okay, let's try this. In 90% of the cases, you got it the first time right.
Cool. Barry has a question. Go ahead, Barry.
Yeah, Hob, thanks very much for a nice presentation and a list of all the maintenance items. I was wondering whether you had something like a ranking order of the most frequent maintenance items on ACC, or failure ranking, or in terms of forced outages or maintenance outage. That would really help the industry to know where any research and stuff was needed?
Barry, it's a good idea. It's actually you're actually waking up an idea I may be having already for a long time. It's only having, say, the resources to put it all together. But yes, you're right. We actually, at this very moment, we are actually working together with a brand new plant in Germany, where the contractor built it. They actually introduced certain technical features of which we say, yes, you can do that, but you have to calculate. You have to not overdo it. And this is actually resulting in the problem that this plant, it was an extension of an existing one, doubling up. They actually installed this extension, and then suddenly, because the steam flow was the same, so the vacuum system should also be suitable for the extension as well. But it didn't. It created a lot of cold spots in the bundles. The normal operating evacuation system was not capable of keeping the vacuum. Performance went down 40%. It was a disaster. And so we went there and said, well, they said, well, what can we do? Brand new, and nobody knows the solution. He said, well, let's try first to start up an additional vacuum system, or to say even because at that pressure it was possible to have the startup injector in operation. We did that, and the unit was perfect, back to system again. So based on that, we found certain, say, layouts of the system that were not according to, say, the technology. Don't forget, an ACC is a system where you have an exhaust spitting out steam at a very low pressure, at a very high speed, with a very low density. And then you expect that flow to go through a heat exchanger, a double one, okay? And then at the end of the heat exchanger, all the steam is condensed. So you need to make that quantity of steam with such a low density, with such a low inlet pressure, flow through the whole system from the beginning up to all the way to the end. And that is something that is not easy to do that in a good way, that you have steam all over the place, so that the steam is actually condensated wherever you have thin tubes. And that was their main problem. There were a lot of disturbances in the flow. But okay, what you just said, Barry, I think it's a good idea to think about it in more detail.
Yeah, good.
And,
No, I think it is. You know, like for other systems that are equally complicated, like a boiler or an HRSG or a steam turbine, we have a ranking order of the major problems. And the subsequent secondary question was whether you think there is anything that ACCUG can do to help in the assistance of developing something like this.
yeah, certainly. Yeah. There are so many examples of this. One last one. It was a plant in Finland where they requested us to replace the bundles. I told them why. Yeah, okay, they're leaking. They're leaking. Yeah, we sure they are leaking. We want new ones. Okay, we did that. Then after just a short commissioning, we saw the condensate coming from the main ducts through the insulation all the way down. So I told the guy, I said, well, you know, the point is, this was a project quite nice for us, but not for you. You did it for nothing, because it was not the reason. And apparently it had cracks in the compensators. But they couldn't see that because it was all lagged. So it was under the insulation. So they couldn't see that. A thing like that. This is typical a point, what I said to them as well. Next time, do some thorough investigations. There are ways to measure this. Don't just think this is the cause and let's put some money on it and replace it. So yeah, Barry, I think it's a good proposal.
Thank you.
One last question before we move on to the next presentation. What is a good estimated minimum torque for a backstop on 30 feet fans?
Ooh, 30 feet. Yeah, actually, I can't give you a figure, but what we normally do is we actually use the backstops supplied by the supplier. and that backstop is then discussed with them, and it depends on the say the moment of inertia. It's like the maximum speed, and you want to stop it. So yes, I can actually find out. Shouldn't be a big problem, but there are some. I must say the backstops we nowadays buy are quite good. They hardly ever fail. In the past, we had systems where when the electrical engineer did not connect the motor correctly and the thing started, say, in a backward direction, with a little bit of waiting, the backstop failed. You had to replace it. So I can't give you a figure, but if you're really interested, I can find out.
Yeah, so Francis, if you want to reach out to Hoob later on, you can.
Yeah.
Thank you. Really good presentation. Really appreciate your time. Thank you very much.
Okay, pleasure.
All right. Okay, moving on to our next presenter. It's going to be Mohammad Reza Wagar from Iran. He's going to talk about ACCs in Iran, optimization and challenges. So if you want to go ahead, Mohammad, and pull up your presentation on your screen.
Okay, hi Rishi. Let me share my presentation. Share. Is it okay or not?
It's still trying to pull it up. It says you're starting to share content, but there's nothing in the background.
Do you hear me?
Yeah, we can hear you. Did you want Scott to pull up a presentation on his screen, and then you can have Scott move through the slides? Mohammed, are you still there?
But now, do you see the?
Yeah, we can see it now.
Okay. Let me check. Do you have my presentation or not?
Yeah,
No,
we do.
I have to send
Yeah, we can see it now.
I have to send it for Scott.
No, we have it. You can go ahead and
Okay.
present.
Okay. Oh, okay. Let me start my presentation. Okay.
Yeah, go ahead.
Okay. Cool. Hello, everybody. Welcome to my presentation. Thank you, Mr. Havel, to provide me an opportunity to be here. It's my honor to present in this conference. My name is Mohammad Reza Wagar, and I am head of cooling system department at Mapna Group in Iran. Mapna Group is a group of Iranian companies involved in the development and execution of thermal and renewable power plants, oil and gas, and other industrial projects, as well as manufacturing main equipment, including gas and steam turbines, electrical generator, HRSG, gas compressor, and other pertinent equipment. Here, I would like to talk about the study of air-cooled condenser in Iran. Next slide. My lecture is divided into 4 sections. First of all, I'm going to give you an overview of short history of cooling system in Iran. Then at the second part, I will review air-cooled condenser projects, which is implemented by Mapna Group. Next, I will focus on optimization and development performed by our team. And finally, at the last part of my presentation, I will speak about challenges we face them in our projects. Now, let's move to first part, history of cooling system. You can see Mapna of all different cooling systems once through. Do you have my pointer? Do you see my pointer?
Yeah, we can see it.
Okay. Okay. Once through wet, Heller, and ACC. I lost. Green signs are about once-through cooling system, which are located next to the Caspian Sea at the north of Iran and Persian Gulf at the south of Iran. One of them was built by our team. As you can see, the green sign here next to the Caspian Sea at the north of Iran. This was implemented by MAPNA Group. Moreover, okay, let's move back. Moreover, the blue signs show wet cooling systems. Due to the water limitation, the construction of this kind of cooling system has been stopped. So there isn't any recent sample of wet cooling system. And the red signs are about Heller cooling systems, which were popular for decades in Iran, and MAPNA played an active role in this field. And finally, the purple signs indicate air-cooled condensers, that all of them have been made by MAPNA Group, except 3 of them. All these cooling systems together contain more than 50. Okay. I have to mention first cooling system was built at 1959 in Tehran. The type of this cooling system was wet, and it was implemented for first the steam cycle power plant. Note that this power plant is consisted of 4 12 megawatt units. And actually, at present, 2 of them are working. Let's look at the next slide, which shows that first air-cooled condenser was built in 1985 at northeast of Iran, as you can see here with purple sign. This multi-row ACC was built by Balkedor company. After that, other single-row ACCs were built for steam and combined cycle power plants in another place of Iran. As I mentioned before, except 3 of them, all other were built by MAPNA Group. After a brief history, let's take a general look into power plants in Iran. Fossil, hydro, renewables are sources of energy for power generation. As you can see in this picture, fossil is the largest source, almost 80% of power generation in 2020. The main fuel of these power plants are gas, and also in cold season, fuel oil and mazut may use too. As you can see as a green, renewable, you can see this line at the bottom of this chart. Renewables is another category. Wind and solar sources have been trending recently, but obviously the growth is slowly and it needs more investment. In this section, I have to note MAPNA built a 2.5 megawatt wind turbine as well as their blades. Moreover, there's another interesting fact we should take a look. During last year, at peak power consumption time, production is less than consumption. You can see the values here, these 2 values. These 2 important values show that Iran needs to modify consumption pattern, increase power plant efficiency, and need to build new power plants. Let's move to second part, air-cooled condenser project built by MAPNA Group. As you can see in this chart, Based on fan diameter, we can divide our projects into 30, 34, and 36 feet. But as indicated by legend, this legend, 34 and 36 projects are under construction and will be commissioned within a year. In another classification, we can also divide our projects into linear duct and non-linear duct. Okay, MAPNA ACC specification. ITD range in our projects is between 20 and 30 centigrade. Our tube bundle are single row, and moreover, I can say we use both double speed and VFD motors and concrete and steel columns. And our evacuation system is a typical form, one hugging ejector and two holding ejectors. Okay. In addition to this, I would like to say at the beginning of each project, different ACC arrangements have been checked to find optimum size by our team, and always we use CFD calculation to rearrange ACC and boilers according to wind direction. Hot air recirculation and fan flow rate are some parameters that have been checked at this step. You can see one of our CFD studies at these two pictures. The effect of boiler location and wind direction are shown at the right picture, and you can see the effect of hot air recirculation at the left picture. Okay, next part. Optimization and development. At this section, I would like to review some of our optimization and development projects performed in our previous projects. For example, in one of our projects, which is located in a hot area of south of Iran, we got feedback which indicates that ACC efficiency followed by a steam cycle decreased during warm seasons. The problem is illustrated in this chart, as indicated by green color. This color line. When ambient temperature goes up more than 46 in situation that wind velocity speed is high, condenser back pressure goes up to 39 kilopascal. At this moment, operator has no choice to decrease cycle load, which is called run back. Okay, you can see the ambient temperature in this column. As you can see, ambient temperature is about 40, 45, 46, and maybe ambient temperature goes up to maybe 49. And wind speed, as is mentioned in this column, is about 5 meters per second, or maybe higher, 11 meters per second. And at this situation, condenser vacuum, this column, goes up to 38 kilopascal, and at this situation, operator decrease the load. As you can see, active power in megawatt in this column. Operator decrease load from more than 100 megawatts up to 84, 83 megawatts. To study this problem, first of all, we analyze crosswind and ambient temperature. We find out that sometimes crosswind and ambient temperature simultaneously increase more than design condition value. As you can see at the right table, maximum ambient temperature and design wind speed velocity is 43 and 3 meters per second respectively. And as you can see at the left graph, high crosswind speed and ambient temperature happen frequently during summer, contrary to our expectation. As you can see, I talk about this area, ambient temperature more than 43 centigrade, and crosswind is upper than 3 meters per second, this area. This chart leads us to conclusion that design condition indicated by contractor is far from real power plant situation. So it's completely normal that condenser pressure increase more than allowed range. Moreover, further studies show that if wind velocity goes up, measured condenser pressure would be upper than calculated condenser pressure by our software. For example, this graph shows us the difference can reach to even more than 40 kilopascal. You can see here this difference. When the wind speed is more than 10 meters per second, which is really shocking, unfortunately. So we start to study, excuse me. So we start to study present the status of ACC performance by using CFD calculation. In this simulation, the geometry includes 4 and 7 module with surrounding building. The left picture presents a solid geometry of the desired section of power plant. As you can see, ACC 4 and 7 module ACC and 2 boilers and steam hall turbine building. And the right shows the computational domain, which is much larger than ACC plant. This was done to prevent the effect of external boundary condition in the vicinity of ACC. I have to note that the fan was modeled as a source of momentum, and its formula is derived from fan curves. I have to note another important thing. Wind direction has been shown as this sign. It's an important parameter, I think. First of all, we should check existing situation. So we study problem with different wind velocity speed. To keep it short at this presentation, I will review only the worst case, which is 20 meter per second wind speed and 40 centigrade ambient temperature. In this situation, we check out 2 important parameters, flow rate and hot air recirculation of each fan. This graph shows the actual duty point of all fans on the fan performance curve, while design duty of fan flow rate is 490 cubic per meter per second, as you can see by red line, this line. At the left side of this line, in this case, some fans are operating close to the stall line. If the fans are in a stall flow, flow decreases dramatically. As you can see, we have some point that flow rate of each fan decreases up to 250 cubic meter per second. And also the sound emission will increase and there is a risk of mechanical damage. Another disadvantage of this situation is poor performance of ACC actually. This slide shows temperature contours at the fan inlet. And as it is very clear in this chart, the hot air recirculation happens extremely, especially it happens to the fans which are exposed to wind. As you can see, these four fans, and at this chart, fan number 25 to 28 have high air temperature at their inlets. So our first approach is to control high wind velocity effect. In this optimization and development project, we suggest different types of wind screen. We study them, and after that we compare the results with each other, and at the same time we compare those results with the case there is no wind screen. As you can see in this slide, in this study, perimeter, cruciform, and perimeter plus cruciform are simulated and studied. Also, we assume that ambient temperature equal to 40 centigrade, while 3 kind of situation are studied, including no wind, 10 meter per second, and 20 meter per second wind speed. Here, I present only the result of the worst case, 40 meter per second due to time limitation. The result shows us hot air recirculation is extremely controlled by adding cruciform window screen, this picture. But the result from cruciform plus perimeter window screen is the right picture is very reasonable. Here in these pictures, you can see velocity vector vicinity of ACC. In compared to no window screen situation, both of these cases have better performance. But this area, where's my mouse? This area and this area are still affected by wind speed, while we do not see such an area in the case of cruciform plus perimeter, as you can see in this picture. For better understanding, let's have a look at the fan flow rate diagram. Pay attention to fluctuation of these three lines and compare green one with two others. Green one, this line, is about existing situation, no window screen. In window screen cases, fluctuating of flow rate are much less than green one. Also, obviously, average airflow rate of these two cases are higher than average of no window screen case. This result is more obvious from fan number 25 to 28, which are directly exposed to wind velocity, as I mentioned before. As a result, cruciform window screen improves the fan flow rate, especially at high wind speeds. It eliminates the crosswind impact on the ACC performance, and also it has a very positive impact on overall flow rates of fan. Adding the perimeter window screen does not increase the fan flow rate, but it eliminates hot air recirculation phenomena at high wind velocity. Also, the perimeter window screen prevents fan operation close to the stall point. If I want to conclude very briefly, I would say cruciform window screen is useful for improving airflow rate, as you can see at the middle of the chart. And perimeter window screen is useful for decreasing hot air recirculation effect, as you can see at the right of this chart. Of course, these results are exclusive for this project. This was one of our development and optimization projects. Let me move to a second example. Another problem we face in most of our project is poor performance of ejector, as mentioned in previous presentation. When condenser pressure goes up, holding ejector doesn't work properly. In this case, operators usually add another holding ejector to service, but because the problem remains, they use hugging ejector or maybe decrease the cycle load, but the problem remains too. In this graph, when condenser pressure, yellow line, as you can see, goes up, temperature difference between cooling water from CRT and ejector first stage shell is decreased dramatically. This situation happens while the design difference temperature is more than 20 centigrade. So we lose the first stage of holding ejector, and to solve this problem, we redesign our logic in all of our power plants. We close the first stage motive steam valve when condenser pressure goes up, and of course, in this situation, it is necessary to redesign and improve second stage nozzle of holding ejector. These two are example of optimization and development project which is performed by our team. Okay, now here is challenges, last part of my presentation. To explain our current status, we have designed and built different cooling system for 25 to 350 megawatt steam turbines, as indicated by green boxes. You can see ACC A-frame, 30 to 36 fan diameter feet, ACC, and different kind of Heller, hybrid system, wet cooling system with Heller. But now our goal is to extend our activities to V-frame ACC, hybrid system, combined wet and ACC, and hexacool system. As you can see by purple boxes, reframe ACC is new for Mapno. Combined system with ACC also new, and also hexacool. Another interesting field that Mapno Group want to extend their activities is changing old industrial wet cooling system. Because of water crisis in Iran, most of the refinery, petrochemical, and other industries have serious challenges with their old wet cooling systems. And now we are negotiating with them to modify this cooling system. So it's a new field for Mapno. At the end of my presentation here, I try to give you an overview of cooling systems in Iran. We went through 2 examples of our latest optimization projects in detail. I hope this discussion gives you a clear picture of our capabilities. As you can see, design, procurement, construction service of air-cooled condenser, optimization service with engineering software, 3D modeling, CFD, piping are our capabilities. However, some fields remain untouched, and our team tend to find an opportunity to cooperate with professional companies in this field. Here, my contact info. I would be happy if you want to contact me by LinkedIn, email, telephone. Thank you so much for your interest and attention.
Thank you, Mohammed. That was a really good presentation. Definitely interesting. I know he provided, it's one of the questions is from David. He's asking if he can have a list of plants in Iran which have ACCs and possibly the address and contact info. So I'd suggest get with Mohammed and his email and his contact information's over there. So
Thank you. Yeah.
I had a question about for the first example with the windscreens. I saw the study, but were you able to implement the windscreens, like install the windscreens, the cruciform windscreen, and did the results match up with the CFD analysis?
Thank you, Rishi. We haven't done any windscreen. We are negotiating with contractor to build the first one, but we haven't any information to compare with our CFD calculation.
Okay. Barry has a question. Go ahead, Barry.
Mohammed, thanks very much for a nice presentation. I'm well used to MAPNA, as you know. Just a couple of questions. First of all, is MAPNA the only organization that manufactures ACCs in Iran?
Yes, MAPNA is the only company implemented ACC. We built a tube bundle fan in other company who works with MAPNA in Iran. But MAPNA just EPC contractor, not manufacturing the manufacture of blades, motor, and etc.
Right. And so then, thank you. And so then I have the same question that I asked Hub of whether you have a ranking order of the maintenance activities on the ACCs in Iran. Do you know what are the major problems across the fleet in terms of maintenance or forced outage?
If I understood you correctly, we do not have a specific ranking, but we do lots of maintenance experience, and
Yes.
we have some protocols, some requirements, and I'm really interested to present the next conference about our experience in maintenance system, maintenance
Yes.
of AC. We have a lots of experience about blade broken, damage of tube bundles, and something like this.
Yeah, Mohammed, that was going to be my next question. Thanks very much. We would like to invite you or somebody from MAPNA to provide that understanding of the maintenance activities. That would be great.
It's my pleasure.
Good. And if
it's
Rishi
very
just allows me one more question. On one of your slides, you had an information about Hella. I'm very familiar with Hella, of course. But you mentioned that it was steel tubes. Do you have Hella systems in around with steel tubes? Because usually with aluminum tubes.
We do not have any Heller system with a steel tube. All of them aluminum, but we still working on it, and it's very interesting for us to work to build a Heller system with a steel tube.
Yes, it would be to get away from the very difficult chemistry that for the Heller system.
Yeah. Exactly. In one of our recent projects, contractor at first wanted us to use a steel tube, but after that changed his opinion and wanted us to Heller with aluminum steel.
Yeah, right. Okay, thank you. Thanks very much.
Thank you so much, Barry.
Andy Howell has actually a comment and a question. He says, "Thank you very much for sharing information on MAPNA's work in Iran. Do you have an ACC wet hybrid cooling system actually in design phase yet, or the same with a V-frame? So do you have any wet hybrid cooling systems or V-frame in the design phase?"
No, we haven't both of them, but it's very, very, very interesting for our company, for my team to enter this field and build first ACC hybrid with wet cooling system. And actually, V-frame is very interesting to for my manager.
One other question is, what percentage of the year did you experience high wind and temperature conditions? Did you see performance reduction in the CFD at low wind conditions due to the addition of the perimeter windscreen?
We have done all of the experience, all of the wind velocity, no wind, 10 meter per second and 20 meter per second. But for time limitation, I just presented one of them, the worst case 20 meter per second. But we have done all of them, and I can present in future. But as I understand correctly, during the summer, at least 3 months, we have a high wind velocity at this project, and the power plant has lots of problem during the summer, these 3 months.
Okay, yeah, that answers it.
Is it clear, or I have to explain more?
Yeah, I guess the second part of the question was, did you see a performance reduction at low wind conditions due to the addition of the perimeter windscreens, or what was like the performance at low wind conditions with the perimeter windscreen?
Yes, we have some low wind additional perimeter windscreen. Yes, at sometimes perimeter windscreen not very useful for our problem. So we have to change windscreen and use perimeter and cruciform plus both together to control and improve the situation.
Okay. One more question from Andy. Is there a preferred cooling system for the new units?
Yes, we have one new category, 44 fan diameter. We prefer this size, 44. Actually, excuse me, 34 fan diameter feet. We prefer this size.
Okay. Yeah, I think that was the last question. If anybody else has any question, they could raise their hand or type it in the chat. If not, I think we can move on to the
Rishi,
discussion. Yeah.
I wanted to ask a couple of things.
Yeah.
So my preferred cooling, so I mean, would you still be doing Heller system? Would that be an option, or would you primarily be going with ACC?
Hello, Mr. Havel.
Hey.
It's my pleasure. Nice to meet you. And Heller system is we work very rarely, and most of the cooling system contractor order is ACC.
Okay, and then another question: who operates the plants? Is it different companies, or is it a government related organization? That MAPNA does not really get involved in operation, right?
We have some private company operates the power plants, but MAPNA Group has a different company, O&M company, which is operates most of the power plants.
Okay.
And we have connection with them, and sometimes have a meeting and to operate and improve the power plants and ACC performance.
All right, thank you.
Yes.
Thank you, Mr. Robin.
Thanks a lot, Mohammed. I really appreciate you sharing your presentation and the studies. And thank you for presenting. We can move on.
Thank you so much.
Yeah. We can move on to the discussion portion. Go on for about 20 minutes and we break. I mean, one of the questions that was asked, I didn't really get a chance to get to, was on the ACC gearboxes, what is the recommended way of measuring oil level? Due to the short range between min and max level and foam formation during operation, ultrasound sensors don't work well. I think that was addressed to Hoob.
Yeah, the normal way of measuring the oil level is just the old-fashioned dipstick, which is actually equipped with every gearbox. Yeah, there are some other ways, but the point is that you know, the level during operation is not the same as afterwards. So it is a critical item. I agree. We have seen gearboxes varying from 60 liters to 35 liters because of people not knowing what they were doing, and even the supplier didn't really know. So the dipstick is a good system. The main system is that you have a pressure sensor in the system, as long as you have the required, say, oil pressure in the channels, in all the tubes going to the bearings, it's okay. What kind of oil is still left in the sump is actually not such an important issue, as long as you have pressure in the system up to the bearings.
Okay. Thank you, Huub. And I just had a question about the last, the cooling technologies. Heller, for those of us that don't really know what the system is, Andy or Barry, do you know how that system works, or like what is the sort of the design of that Heller system?
Yeah, Richie, we know very well. I didn't want to take too much time. We've done a lot of work, or I've done a lot of work with the Heller systems and work for the old EGI company in Budapest. It's basically a system where the cooling is done in aluminium tubes, which are placed in a cooling tower, a hyperbolic tower. And as Mohammed recognized, there was a lot of work done to get the chemistry correct. You have to operate with a completely different chemistry than what we're talking about for ACC. And basically, you have to operate with a much lower pH and a high oxidizing system to minimize the amount of aluminium that's into the cycle. But they're used. Iran is one of the main places where Heller systems are used. They're in Syria and in China. The latest one is on supercritical units in China, and so they can work across the whole range. But we've actually had the people from Budapest come and make presentations at previous. I don't really think we need to spend any more time, Rishi. If you or anybody wants the information, that you can contact me, and I can probably answer or put you in touch with the people in Budapest.
Okay. I was just curious.
Is that okay?
Yeah, that works. Yeah, I don't think I don't see any more questions in the chat that didn't get answered. Andy, are there any discussion items we should talk about, or should we just break?
I think we had some very interesting discussion there, Rishi, in terms of those maintenance items. There's no overall country or world body that's collecting this reliability information, and that impedes us in terms of moving forward, in terms of providing increased reliability. Like you're familiar in the US, there's organizations that collect reliability data. I've set lots of them up for tube failures in conventional plants and in HRSGs. And they really help us to steer the direction to provide guidance for these plants. And it would be very interesting, I think, for ACCUG to either assist in that or be involved in that. And I think you heard Hub indicate that he'd be very interested. And the people in Iran, if they would be allowed to provide that information, I think it would help the whole ACCUG community. That was quite an interesting thing, I think, that came up. We'll have to, as a steering committee, I think, look at it and see if there's anything that we can do along those lines. That was quite interesting.
Yeah, that'd be a good for even for people who like operate the plants. See, that'll be a good sort of document to go off of when there is an upcoming outage, just to go through those items and do sort of the required, inspections and rebuilds and whatnot. One of the questions that's been asked is, do any of the users want to share the most common failure modes on the gearboxes based on our experience?
Are you asking that me?
Yeah, you can go ahead and answer it. I think it was just for a general question for the users,
yeah,
like what's
yeah.
some of the most common.
Yeah, if you contact the operators, they are more than happy to share their experience. However, I must say their knowledge about the actual functioning and all the possible problems is very limited. And I'm not many, say, operators that register everything they do. You have to go there and ask, and then you get an opinion. And you actually have to make your own decision what's going to be done and wrong. And one of the nice sources is when a gearbox fails and the operator decides to have it overhauled, that you go to the overhauling company and have a look inside and talk to the people, see their measurements, and say discuss with them what has happened and what can be prevented. And that's actually the source of the most of the technical details of gearbox failures.
Yeah, I think one of the other things, at least in our fleet, I can talk about is we have a tech collect vibration data, but then we don't have the expertise to diagnose vibration data and try to and figure out what the actual problem is, if there is a problem. So something like this monitoring system, something like Howden has or Howden's going to implement, is collect that data and have that software do the diagnosis for you, and then and then it kind of puts you in the right direction or points you in the right direction as far as what issues you might be having. But vibration in itself is like you'd probably need like a specialist and a couple with experience to be able to sort of diagnose issues.
Maybe we can actually collect a list of pieces of experience in the coming months and share that with all the other people. Because the point is that there's such a variety of problems that can occur. I remember in 1998 when Sumitomo actually sold gearboxes for the Enfield power plant project, and they start failing after 6 weeks. And we actually investigated the problem. And the problem was that gearbox was vertically separated in two halves. And if you got, say, a cast iron construction, which is built up with two vertical, say, parts, on a structure from steel that is actually very flexible. Even that structure is hanging in another structure of steel, also very flexible. So the movement of that gearbox is very complicated. And actually, it actually caused the shafts of the gear to be not 100% aligned. And that's actually where actually the gears themselves were not in contact completely for 100%. And that's actually caused, say, certain particles to break out and failure of the gears. And this is a typical thing of a typical design problem. Okay, after that they bought another company, and now they're building, say, very good gearboxes, I must say. But the point is that there are so many little things that can actually contribute to the failure of a gearbox. And I must say the industry has been developing quite good. And this week I got an inquiry to replace a gearbox, which was in operation for more than 20 years. That is quite good for a gearbox. Even the supplier was quite proud of it. He said, well, hey, that is a nice box. I said, well, the client would like to have a similar type, actually a copy of this, because another 20, 25 years, and then the whole plant will actually stop. So this is an example of how to do it. And the point is that we do that most of the time together with the suppliers, to talk with them and say, okay, what is your experience with this kind of gearbox, and why this gearbox fail? And then you suddenly see the red line. And the most important thing is, for instance, that we get rid of, say, the direct online on the high performance units. If you see what's happening on a plant with a direct online one-speed motor, you don't believe those gearboxes are going to survive for more than a few years. We even have seen also the Enfield project. They had one speed, 110 kilowatt motors. And after about 3-4 months, we saw that all the gearboxes were actually turned around their, say, bolts a little bit, but they will all move sideways as in reaction force. They all went in the same direction at the same angle. And that was done by just a moment of inertia when the fan starts up. And if you're standing there, you can hear the motor, how it's fighting against the moment of inertia. It is a disaster. It is an immense noise. And then you know something must fail. And those gearboxes had a service factor of 3.5 plus. And they are now in operation for, say, more than 20 years. And they're now thinking of the 4th set of gearboxes.
Wow. Interesting.
Yeah, quite interesting. Yeah.
Yeah. James Anderson has a question. James, do you want to unmute your microphone and ask your question?
Sure, and this may be more related to corrosion, but I missed the discussion period the first day. We observed some pinhole leaks on our tubes, like mid-span. Has anybody seen that? Is that probable of FAC, or it's a Hammond ACC? We really had pretty good luck with it overall, but we did observe some pinholes. And I don't know if they were always there and we just never noticed them, or if they're new, and what might be the probable or possible causes.
And how far were they from the tube entries?
They're like midway. They're kind of scattered, but kind of midway between the upper and lower header.
It's highly unlikely that it's anything to do with FAC at that location. And what about the surfaces? Were they covered in deposits like we were talking yesterday, or were they clean and shiny?
They looked pretty clean. I mean, I guess there was a little bit of rust color around the perimeter, but very, very small. But we never cut them out to see what it looks like on the inside.
Did you look with the Boris?
If you were to have a lot of deposits, and the deposits were likely to stay moist, not very probable. But if they did, then you could get some pitting reaction at the base of those deposits. But we don't usually see pits there. I think you're going to have to cut out a tube and send it to me, and then we'll tell you what it is.
Okay.
Did you look with a video probe, James? Did you look inside them?
No.
Do you know if it was internal or external origin?
No, I really can't tell.
Okay. Either way, that sounds pretty unusual. So if you have multiples, it might be worth investigating to resolve.
Okay. Well, it looks like we'll try to see if we can get a borescope down there, and then also maybe cut one out. Okay. Thanks.
Yeah.
Have you plugged
That's
them
the way
now?
to do it. That's the way to do it.
What's that?
Have you plugged them with some silicone or something, or how did you?
We just put some tape over them.
I mean,
And it's holding so far, but we
works.
haven't done a thorough survey to see how many we have, or if we have them elsewhere. We picked up, I think, 5 of them, but we haven't done the whole ACC yet.
I know at my plant, we were having some air leakage issues. And we couldn't find out, even with the helium testing, we couldn't locate the leak. But when the plant was down, I went to the ACC with a UT gun, and I did notice there was some small pinholes, not on the tubes themselves, but the outlet header at the bottom. there weren't very many, but there's probably 3 or 4 that we plugged using epoxy. But yeah, apart from that, was your pinhole leaks like large enough to cause like a increase in like back pressure, or did you
Yeah,
just
certainly
notice?
not noticeable anyway.
Okay.
So Barry, do you also work with structural integrity?
Yes, I work for them.
Okay, just curious. Okay.
All right. Do you still want to? You can send me a tube, and we can look at it for you if you want.
Okay. All right. All right. Well, thank you very much.
Yeah.
Miguel Arroyo has a comment. My oil test analysis of gearboxes show 5 ppm iron or less. Almost always on the 40 gearbox we have. Isn't it too low? With 6 years of operation and 3 years oil age, I would expect more particulate. So maybe somebody from CC Jensen could answer that question about his ppm on iron. Is 5 ppm iron too less on his oil test analysis? Or anybody else?
I don't have a lot of experience with that gearboxes necessarily, but I know the iron can get pretty high, and it also can be challenging to get a good sample. But I don't know if they're used to doing that, and it's the 40 gearbox. Does that mean one specific gearbox, or does that mean all the gearbox? I'm not quite clear what that means.
Yeah, it looks like it's almost all of them.
Yeah.
They show 5 ppm, and he's I guess his point is with 6 years of operation, he expects more.
Okay. Yeah, I would say a trend is really a significant thing. I'm not sure about the absolute number though.
Okay. Yeah, it looks like we're at the top of the hour. Think we can break for about an hour. And Scott, did you have anything?
No, we're fine. We're going to break for an hour and come back for the second half of day 3. We've got 2 more presentations left and some more open discussions. So please bring your questions, and we'll see you back here after lunch.
Thank you, Scott.
Yep. Thanks, everybody.
Yeah.